Welcome to the case study, the part of this course on analysing transients in pressurised pipe systems, where you will get your hands and analytic skills working. The case study is presented using this workflow. You will start by initialising a model with its basic setup information. Then you will build the model by adding assets, land elevation data, customer demand parameters, and automatic control logic. These are the steps that take the most time. Then the interesting parts commence and happen quickly when you simulate and review the steady state hydraulics. Note the slide refers to many steady states. The software, when it does real-time simulation over an extended period, is creating many sets of steady state data. You can use any one of these steady states to be the starting point for simulation of a transient event. In the case study, you will simulate and review the results of a range of transient events. In cases where the transient results don't match the system's design objectives, that is when the case study will move on to adding surge protection. The case study winds up with looking at assessing the non-return valves in a pump station, examining how the fluid dynamics in the system affect how fast the non-return valves need to close. In most, if not all engineering projects that involve transient analysis, your workflow will look like this. The general progress is downward through the list of successive steps. However, you will find yourself looping through the process a number of times until you find your preferred engineering solution. When you get to the section in the case study that adds surge protection, the study leads you through 3 scenarios, using an air valve solution, an air cushion solution, and then a pressure vessel solution. These examples are chosen because they are the surge protection methods most frequently implemented by industry, because they tend to be effective and economical, meaning you should end up with skills that you are likely to often use in your future work. Project teams will not have assessment and selection of non-return valves in their scope of work on every engineering project. The case study will show you how to assess some typical pump station scenarios, including a pump failure event, looking at the consequences of slow-acting non-return valves, and the improvement created by fast-acting valves. And then a more regular event of one duty pump stopping automatically while a parallel duty pump continues to run. These will be good skills to have if you ever work on a very large pumping station where the capital cost of appropriate or inappropriate non-return valves can be significant. It pays to do the required transient analyses well before the project budget becomes fixed and final. So what type of system will the case study cover? The case study's system starts with 2 tanks, a suction tank plus a higher summit tank. Throughout the case study, your mission will be to undertake the transient analysis of the steel pumping main and the pump station which transfer water into the summit tank. The pump station and the summit tank supply this drinking water reticulation zone. The zone boundary and its PVC pipe routes and diameters have been designed by others. You will use their work as presented. However, the steel pumping main is not isolated from the pipes in the reticulation zone. It is an inlet-outlet main. Consequently, transient behaviour of the pumping system will depend on customer demand within the zone, and the reticulation zone will experience the effects of pumps starting, stopping and failing. Here is what the system looks like in its broad geographic context. Flow rate through the pump station will be relatively high because the summit tank supplies its own reticulation zone plus transferring water into a higher zone, shown here. That higher zone and its assets are beyond the scope of the case study. Our focus will be on this system and its pumping main across steeply rising terrain. Most of the properties in the reticulation zone are zoned for single residential use. There is some public open space and only a few special use lots. The case study will provide the pipe layout, diameter and pipe type of the network of pipes in the reticulation zone. In addition, the location of each water meter will be provided, along with data about the type of property served by the meter. In terms of how you need to approach the case study, here is the recipe. The order in which each module and its components are presented is important. They build on each other in a logical sequence. As a result, you need to do each module in the order presented. In particular, the first component in a new module will typically explain your mission, the engineering task that you are required to complete. Within each module and its subcomponents, the same approach is needed each time. Read, watch, and do. That is, read what the workbook describes for that part of the case study. The workbook will present the engineering mission, plus instructions on each step required to use the WATHAM user interface to complete the mission. Then watch the tutorial video. It will be a visual repeat of the recipe described in the workbook. The advantage being that you will see the user interface applied in action. Plus you will be able to rewind and replay parts of the video if you need to. Finally, apply the recipe and the tutorial by doing that part of the engineering mission yourself. At some places in the workbook, there are questions with space to record your answers. Write your answers into the workbook as you do the tasks. Later, you will be able to copy those answers from your workbook into the relevant online quiz. The purpose of the case study's online quizzes is to provide JCLEM Consulting with feedback on your progress. These quizzes are not marked or graded. They, however, let JCLEM Consulting know whether you are applying the analysis tools accurately or not. Finally, approach the case study with confidence, despite being unfamiliar with the user interface. Don't worry about what will happen if you end up with wrong data or wrong assets, or have them in the wrong spatial location. Case study data sets are provided for you to make or break. If you break a data set in one part of the case study, there is always a life raft provided for the next part of the case study. There will be a new, clean, correct data set available for you to start the next part of the case study. For now, that's it from me. It's over to you now to do the case study at your own pace. I hope to see you in one or more of the monthly live chat sessions. You can find their big blue buttons at the front of part 1 of the course, noting that case study is part 2. So look for these big blue buttons at the front of part 1. There will be one live chat, which is a video conference scheduled for the first Friday of each month at noon, Australian Eastern Standard Time. They are your chance to raise questions and gain support from myself and others participating in the live chat.